All right, let's talk about something that's jumped right out of science fiction and into our daily lives: ethical AI. This isn't just a philosophical debate anymore. It's a real-world engineering problem we have to solve. So here's how we're going to break it all down. First, we'll set up our guiding principles. Then we'll look at some pretty spectacular failures. After that, we'll check out the tools engineers are using to prevent those failures. And finally, you're going to get a chance to put on your auditor hat and try it yourself. Okay, first things first. Before we can build ethical AI, we have to agree on what ethical even means. We need a North Star, a set of core ideas that everyone agrees should guide how we create this technology. And at its heart, it's pretty simple. Ethical AI is all about making sure these incredibly powerful systems are built to serve people, not the other way around. We want them to align with our values and our rights. And this isn't just a nice to have anymore, it's becoming a hard requirement, written right into engineering specs and increasingly into law. So what does that look like in practice? Well, experts all over the world have kind of zeroed in on these 5 big ideas. You've got fairness, which is just no discrimination. Easy, right? Then there's transparency. We should be able to understand why an AI made a certain call. Accountability, meaning when things go wrong, someone is responsible. And of course, the big ones, privacy and safety. On paper, this looks like a perfect blueprint. But, and this is a big but, what happens when these beautiful principles collide with the messy, complicated real world? Well, that's when things can go very, very wrong. This is where the theory gets a serious reality check. You know, probably the single biggest challenge we face is bias. Because here's the tricky part. AI systems learn from our data. And if our data reflects society's worst habits, the AI learns those too. It finds these sneaky little things called proxy variables, data points that look totally neutral but are actually stand-ins for things like race or gender. And for a perfect and honestly pretty terrifying example of this, look no further than the Optum healthcare case. The goal was fantastic: build an AI to identify high-risk patients who needed extra medical care. What could possibly go wrong? Well, here's the flaw, and it is a huge one. To figure out who was sick, the AI used a proxy, how much money they'd spent on healthcare in the past. Now, on the surface, that makes some sense, right? Sicker people probably go to the doctor more, so they spend more. But that logic completely ignored the fact that, because of historical and systemic barriers, Black patients in the U.S. often had less access to care, and therefore spent less money, even when they were just as sick or even sicker than white patients. So think about that. The AI, using what it saw as perfectly objective financial data, taught itself a dangerous lie. It concluded that Black patients were healthier than they actually were. And because of that, it systematically recommended that white patients get prioritized for extra care, steering critical resources away from the very people who might have needed them most. Okay, so bias is a massive problem. But there's another equally tricky issue: liability. When an autonomous system makes a mistake, who's to blame? Is it the owner, the programmer, the company? This question leads us to this really interesting concept engineers call the moral crumple zone. Just like a car's crumple zone is designed to absorb impact in a crash, the moral crumple zone is where all the blame gets absorbed. And usually, that's the closest human. This idea really came into focus after that tragic Uber self-driving car crash. The car's complex system failed to react properly, but the legal and moral responsibility was crumpled almost entirely onto the single human safety driver, who was expected to react perfectly in a split second when the multi-million-dollar system couldn't. So yeah, after hearing all that, it's easy to feel a little down about this stuff. But here's the good news. Engineers are not just sitting around letting this happen. They're actively building a toolkit to fight back and create safer, fairer AI. And some of these tools are really cool. First up is red teaming. That's basically hiring professional hackers to try and break your AI to find all the flaws before it gets out into the world. Then you've got explainable AI, or XAI. These are tools that help us crack open the black box and actually understand why an AI made the decision it did. And my personal favorite, modelcards. Think of it like a nutrition label for an AI. It tells you exactly what's in it, what it's good for, and crucially, what its limitations are. All right, we've covered the principles, the pitfalls, and the tools. Now it's your turn. We're going to put you in the driver's seat. You're now an AI auditor, and you've just been handed a new product pitch. Let's see if you can spot the problems. So here it is, the pitch for Future Leader AI. The idea is to revolutionize college admissions by predicting which applicants will become high-value alumni. How do they define that? Simple. A good GPA and a donation to the school within 10 years. It's trained on 15 years of past successes, and it looks at two key things: an applicant's vocabulary and their zip code. Then it just automatically cuts the bottom half. So, what do you think? See any red flags? Okay, let's put on our auditor hats. Where do we even begin with this one? There are so many layers here. Let's break down the three biggest, most glaring ethical flaws baked right into this thing's design. Yeah, laid out like this, future leader AI is just a disaster waiting to happen. First, look at what it's trying to predict: donations. That means the AI isn't optimizing for intelligence or potential, it's optimizing for wealth. Second, the training data. By using only past successes from the last 15 years, it's just going to find whatever patterns existed then and probably automate the biases of a less diverse student body. And finally, the killer: using an applicant's zip code. That is a massive flashing red light. It's one of the strongest proxies for race and income that exists, basically creating a digital version of redlining for college admissions. And this really brings us to the single most important question anyone in tech can ask today. It's the real North Star. For decades, the challenge was always, can we build it? But now, with AI, that's changing. The most important, the most difficult, and the most human question we have to answer is, should we?